Good afternoon, Dr. Gautam.
Am I audible, sir?
Yes, sir, you are audible.
Okay, sir.
And if you want to check your this screen sharing option, you can check. I have assigned you the presenter rights.
Yes, sir. Screen sharing is also visible.
If you want to share your screen.
Okay, sir.
Yes, sir, your screen is visible.
Okay, sir. Nice meeting you, sir.
Same here, sir. Very good afternoon to all the distinguished dignitaries and the panelists present here, as well as our participants who have gathered for this 3-day online training program. I am Anil Kathay, Junior Consultant, Center for Hill Area Development, National GMR Division, National Institute of Disaster Management, and I welcome you all to the 3-day online training program on disaster management, focusing power sectors. That is organized by National Institute of Disaster Management, Ministry of Home Affairs, and Delhi Transco Limited, New Delhi. As you know, power sector is one of the most important and infrastructure of the country. As the growth of this power sector, power industry is directly correlated with the economic growth of any country. Any disruption in this industry due to any disasters or emergency scenario can create hardship to the local communities, as every aspects of human life is directly or indirectly today is associated with electricity. And as you also know that India is one of the disaster prone country in the map of globe. Due to our unique geoclimatic and socio-economic attributes, as well as huge population. We are marked as one of the highly vulnerable country to different hazards like earthquakes, then landslides, floods, droughts, cyclones. And on an average, 2% of our country's GDP is lost due to adverse impacts of the disasters. And as you know, recently there was a UN report of human cost of disaster. According to that report, India stands third after China and America in the number of disasters incidents reported between the time period of 2000 to 2019. So all this scenario, it comprehend the vulnerability of India to various disasters. And when you talk about the disaster management setup of the country, so our disaster management setup has its roots in drought response and famine management that was in late 18th century during the British period. They set up a famine commission in May 1878 in response to the famine, which was the most prominent disaster at that time. At the time, like I mentioned, it was a major disaster, and it was all about the disaster management setup at that time was all about relief distribution. And simultaneously after independence in 1947, the initial focus was on food scarcity and famine. So scarcity relief division within the Ministry of Agriculture was delegated the nodal charge of drought and scarcity management. At that time, the nodal responsibility of disaster management in the country was under the Ministry of Agriculture, but with time it was felt that each disaster created complex emergencies and that call for a broader and more holistic approach for effective management. So as a result, the subject of disaster management, excluding drought, it was shifted to Ministry of Home Affairs in June 2002. So till the late 20th century, our disaster management setup was mostly devoted to the issues of relief management. There was no disaster preparedness mitigations, but with 21st century, there were new interventions in the field of disaster management that shifted our focus to a holistic, robust approach of disaster preparedness. There was disaster mitigation and response so that we can minimize losses in terms of human lives, in terms of economic losses, losses of the destructions of infrastructures and structures. So this 3-day online training program, it aims to share, disseminate experiences, knowledge, informations, and all the innovations and ideas are related to disaster risk reduction and resilience, in focusing in the power sectors and enhancing the capacity of relevant officials and as well as stakeholders in reducing the impact of disasters at their workplace. So throughout the 3 days, number of eminent speakers, renowned speakers will be joining us, and they will be sharing their vast experience and knowledge with us during these 3 days. So this is an opportunity for all of us to gain and to learn from their experiences and from their expertise. So in today's technical session, there will be 2 sessions which will be taken by our experts. Before I pass on the stage to our first experts, I request all the participants, please be active in a technical session, and you can raise your queries either through chat box, or you can also use our Q&A box to raise your queries. Okay, so that the flow of knowledge, the flow of the dialogue should be both ways, not from our expert side, but you can also contribute in this. So the first speakers of today is Dr. Harjeet Kaur. She is currently working as a junior consultant in Coastal Disaster Risk Reduction and Resilience Center of GMR Division of NIDM. And prior to this, Dr. Kaur was working in landslide risk management in Northeast region of the country. And Dr. Kaur has also published over 16 research publications in reputed journals. And she is also recipient of a number of awards, fellowships, professional recognitions, such as Young Scientist Award. And she is also gold medalist in UG and PG studies, as well as she is also having Inspire Fellowship. And today, Dr. Kaur will be providing insight on disaster risk management, and she will be highlighting the elements, the concepts of disaster management, and particularly focusing the power sector. So with these words, I pass on the stage to you, Dr. Kaur.
Thank you, Anil sir, for giving me this opportunity. So, as sir told that my presentation topic is on disaster risk management elements and concept focusing for power sector. So I think mostly we are familiar with the words natural hazards, floods. So here we basically focused for hazard in power sector. So before entering to the technical part, I would like to spread the message of COVID appropriate behavior among our participants. So here I would urge all the participants, friends, to wear your mask properly and used alcohol-based sanitizer if water or soap is not available, or you can generally wash your hand with soap and water thoroughly, and avoid touching of sensitive organ like eyes, nose, mouth, and maintain the physical distance. So socially we are apart, uh, and then we should regularly clean the surface and well ventilated. So this is all the COVID appropriate behavior led down by Ministry of Health and Family Welfare. So as I have told, here we have focused for the disaster in power sector. So basically you have seen that I have shown you pictures of natural hazards and man-made hazard. You can take an example of fire. So this disaster in power sector can occur due to this natural hazard, or you can say man-made activities, or with the combination of both natural and anthropogenic. So first I have given the picture of earthquake, flood, tsunami. So these hazard can contribute disaster in the power sector. And on the other hand, the crisis situation can rise in power sector with the event of like a terrorist threat or attack, you know, fire, cyber attack. So let's discuss how this natural calamities impact on power sector. So we know that flood in our country, it's a natural disaster and it causes more devastating or damages to property, life, infrastructure as compared to the other hazard. So flood along with tsunami or the cyclone, that are main water related natural disaster, natural hazard in our country. And then landslides, avalanche mainly occur due to the geotechnical instability. And the water related disaster are climate related, that we have gone through from the newspaper news article that we have read ki, yes, due to the climate change, precipitation is increases. So this water related disaster is interlinked with the climate change, and on which mankind has but little control. So one can only try to manage them and reduce the severity only to a certain extent. So the impact of these disasters and their multiplier effect on economy, national development, and severity of affected infrastructures are well known fact. But we need adequate quantified to provide the financial justification for undertaking the mitigation measures for this particular disaster for particular sector. So event like earthquake, flood, cyclone have been instrumented and studied statistically and scientifically so as to predict their occurrence and intensity with a certain degree of confidence. And however, if various equipment and system of power generating plant and transmission systems are designed after a site specific study, uh, later, I will show you the hazard or vulnerability profile of our country. So why here I'm mentioning that we need for power sector, we need a site specific study, because we have a coastal region, we have a riverine belt, we have Himalayan belt. So we need a site-specific study to account the stipulation of a various code and standard on this subject that damages to the power plant and equipment that could be greatly affected if this could be happen natural disaster, natural hazards. And Then for anthropogenic, let's take an example of bomb explosion. So bomb explosion in a generating station or a substation can lead to a major crisis through disturbance in grid and disruption in power supply. And in the event of bomb explosion or a bomb threat, special measures need to be adopted under the expert guidance. Then, if strikes would happen, so it will by any section of the employees in generating a station in their particular station. So worker could lead to a crisis and can bring the system to grinding halt if adequate step to run the generating station. So this could ultimately lead to a blackout in areas which could be as small as locality or as large as a state or a region. Like natural calamities, fire are big threat and cause loss to human life and property. So, however, disaster due to fire normally remains localized to a particular installation until and unless stripping of the entire power plant causes disturbance in the transmission grid by way of overloading and leading to the tripping of other power station. Then the most common cause of fire is known to be electrical short circuit and fire triggered by the inflammable materials. So the damage caused by the fire accident generally take excessive time for the restoration. Then the most important thing for crisis that is induced by the human for cyber attack. So the impact of cyber vulnerability is proportional to the critically of the function and the system being impacted. So the cybersecurity vulnerability in generation sector are localized and its impact can shut down one unit or a plant. Then we have right now we have discussed how this natural hazard or the man-made activity can contribute to a disaster or in a power sector. So we should understand what is hazard or how would you characterize an event as a hazard. So we have a standard definition of hazard. So according to the UNICEF, hazard is a rare or an extreme natural or human-made event that threatens to adversely affect human life, property, or activity to the extent of causing a disaster. And the next question I have raised that how we would characterize an event as a hazard. So hazard may cause loss of life, injury, damage to properties, economic disruptions. So a hazardous event is the manifestation of a hazard in a particular place during a particular period of time. So let's see how we can characterize any event as a hazard. So here you can see I have listed out some event name like missiles, electronic waste, thunderstorm, lightning, landslides. So we should ask question to ourselves, okay, is this event is a hazard? Suppose measles. So we can we list measles as a hazard? No. Then why? Because if it causes damage to all the community, like just take an example of COVID-19, because it's impacting the community, society, large on larger scale. So that's why it categorized under the biological disaster. But measles, it's only impact on a 1, 2, or 3, 4%. So we are not taking it as a hazard. Then electronic waste. Electronic waste is categorized under the waste category. It's not under the hazard even. But some in the long run will create any disaster, but not right now. It's not listed in a category of hazard. Then obviously thunderstorm, lightning, landslides, earthquake, floods. So these are the events that create a hazard. Then a hazard turns into a disaster when people or died or a person is vulnerable and he's not able to cope with that situation. It will create a disaster. So we can understand this phenomena with these simple pictures. So here you can see a person is just lies behind the hillock, and in the figure F and G you can see a house is built just opposite to the hill. So obviously if landslide occur, then in the figure B the person will die due to this boulder. And if landslide occur in this area, then it means it will damage the house. It will create a disaster. In the C, if image you can see a person is died due to this hill boulder. So that means it will create disaster. So by these things you can easily distinguish in the hazard, vulnerability, and disaster. So, according to the NDMP 2016 National Disaster Management Plan developed by NDMA, they have characterized a natural hazard into a 5 category. So here, these 5 categories are geophysical, hydrological, biological, and meteorological hazards. Then from high power committee, they have characterized disaster into a 5 category. But the hazards are same, but they have classification is different. Like they have classified flood, cyclone, cloudburst, hailstorm, tsunami under the category of water related or climate related disaster. Then they have classified landslide, mud flow, earthquake, dam failure, mine fire under the geological related disaster. Then the nuclear hazard is categorized into chemical, industrial, and nuclear disaster. Then again the biological disaster, the food poisoning, cattle poisoning, pest attack, these are categorized into the biological related disaster. And they have mentioned here accidental related disasters. So these are forest fire, urban fire, and mine flooding, oil spilling, serial bomb blast, so festival related, mainly the man-made disaster they have classified under the accidental category. So according to the UNICEF, they have defined disaster is a serious disruption of the functioning of a community or a society involving widespread human, material, economic, and environmental losses and impacts which exceed the ability of the affected community or a society to cope using with its own resources. So this is the standard definition of disaster. This is the human-induced hazard that I have already discussed. So the level of disaster under NDMP, they have classified the level of disaster, how we can, if a disaster occur in any state or in our country, so how we can distinguish or how we can label these disasters. So they have mentioned a 3 category level of disaster: L0, L1, L2, and L3. So L0 is the normalized situation. It utilized for the disaster risk reduction process. Level 1 is a disaster that can be managed within their capability, that means within the community or within the district, but state are available to help the district resources. Then level 2, that is situations that require assistance and active utilization of resources from the state government. And in L3, that is a very large scale disaster where national level assistance is required. Yeah, now the vulnerability. So this image, the overarching message to be gleaned from this figure is that there is a number of words you can see: the capacity, human, reduction, exposure, and so all these club and give a definition of vulnerability. So basically, vulnerability is the degree of loss to a given element at risk resulting from the occurrence of natural or man-made phenomena. So basically, the vulnerability map is expressed on a scale from 0 to high. 0 indicates the low vulnerability and 1 indicates the high vulnerability. So later I will discuss. Yeah. So how we can assess or analyze the vulnerability of any area. For suppose we are taking for the power sector. So the basic thing is vulnerable population who are at risk. So in our organization, we should prepare the vulnerable population, like the employees, those are vulnerable, like old age people, you know, mostly from, you can categorize the vulnerable population on the basis of their age. If some disabled person are employed in the uh, section, so we should consider that disabled person under the vulnerable population. Then we should then next vulnerability is infrastructure. What is that? Risk. So if suppose your building, you can take an analysis of your surrounding, your office. So you can found that this building is very old. So and we this our office falls under the earthquake prone area. So we should take care for our land use planning for that area. So you can characterize that building or your that office under the category of vulnerability, physical vulnerability. So basically, the scientist or the researcher classify the vulnerability into basically 4 types: physical, social, economic, and political. So, but for power sector, we can also classify vulnerability similarly with these criteria, like physical vulnerability. Here we can consider the infrastructure. We can also use the instruments in this physical vulnerability. Then social vulnerability, which indicates the employee of your sector. You know? Then economic vulnerability, here we are considering, because this is, we are talking about for the power sector. So obviously we invested so much money in infrastructure, in instrumentation. So we can list it out that highly valuable things in economic vulnerability. Means we should prepare the checklist for the vulnerability. Then I think political vulnerability is not involved in power sector. Next, definition means mostly the researcher or the scientist used approaches to assess the vulnerability is basically they can do with some kind of matrices, indicators, and curves are there. Then here TRM, that is capacity. So as from the definition, I have told you how we can, if we are the community or a person, it's not able to cope with the disaster situation, that falls under the category of capacity here. So here, capacity in one word, we can see ability of coping and responding to reduces the losses from any event, maybe a natural or anthropogenic event. Then in this we can also say capacity is the strength or the attribute and resources available within an organization for basically for the because we are here talking about for the particular sector, so we can say the combination of all the strength, attribute and resources within our organization to reduce the risk from any disaster and make ourselves resilient to particular disaster. Then here I have mentioned a slide for the specific risk, because here we are talking about for the specific sector. So we should know what are the risks associated for the power sector. As in the first slide, I have told that these natural hazards that they can create disaster in the power sector. So basically, if our power grid is or our office is under the earthquake prone area, built under the earthquake prone area. So here we can only go for the specific risk, means analysis, risk analysis for the earthquake prone area. Means the checklist for basically for our instrumented should be focused for the earthquake. Okay, for landslide, it's a different checklist. Then for the flood, the vulnerability list and element R risk are different. So we should consider the specific risk for a specific region. Then element at risk. So element at risk like population, properties, infrastructure, including you can take the public services, those are at risk in a given area is known as element at risk. So you can just take an example of coastal belt. So I have shown you a coastal satellite imagery. So from satellite imagery, you can easily restrict out the things those are at risk. So just suppose, because mainly the coastal belt is affected by the cyclone hazard. So here you can see I have marking the agriculture land, airport area, harbor area, so and the population area also this color. So these things, these you can say these attributes or infrastructures, population, or you can take in terms of vulnerability, you can say the physical and social vulnerability. So these things are at risk due to cyclone or a coastal area. So likewise, similarly, you can take a map of your particular region and you can list out associated hazard with your area or organization. So this is similarly for coastal area. So how we can prepare the hazard, disaster and vulnerability for coastal belt area. So the thing is how we can do a risk analysis. So here risk analysis means the identification of undesired event that lead to the materialization of a hazard, the analysis of mechanism by which these undesired events could occur, and usually the estimation of the extent, magnitude of these harmful effects. So then response. So it is a very good means response, recovery. These are the terms widely used in disaster management. So we should know about these things. So response according to the DM Act, it defined the disaster response as the taking of appropriate measures to respond to any event. And these include actions and measures planned in anticipation of during and immediately after an event to ensure that its effects are minimized and that person affected by the event are get immediate relief and support. So basically, the aim of response operation is to save life, protect the property, and make an affected area safe. Basically, this is the objective of the operation of response. So I think you have heard the word recovery. So recovery is an organization method of regaining access and functionality from any effect of any disaster. It may be a natural or it may be a human-made disaster. So that's why this you can easily define this disaster recovery with the word build back better. Now, the preparedness. So, disaster preparedness here refers to measures taken uh, to prepare for and reduce the effect of disaster. So, how we can do prepare the stages of disaster prepared. So basically, we should identify the risk for our organization. Then second step is after identification of risk, we should prepare plan. Then after preparing the plan, we should implement that plan and train employee, or we can go for the mock drill to train our employee regarding any disaster event that I have already discussed. So this is the hazard and risk profile of our country. So from this you can see due to the geographical location, we are facing every disaster. We faced cyclone, tsunami, we faced flood, landslide. Now Govt terminologies evolved. Then fire, forest fire are there, fire incidents are there. So these are the hazard vulnerability profile of our country. So basically, our government identified the region basis on their severity. So they have identified like we should focus for the Himalayan region because these region has affected by a particular disaster, like these are affected or prone to earthquake, landslides are there, flash floods are there, bluffs are there, cloudburst phenomena is there, lightning is there, cold wave is there. So like these five, they have means identified the region on the basis of the severity of hazards. So then recommendation from my presentation is that we should focused to improve the understanding of the terminologies of hazard, vulnerability, risk, and I have already defined you how we can distinguish these words. And we should provide a clarity on the role and responsibilities of different stakeholders. Those are involved in disaster, to dealing the disaster, and we need an effective hazard assessment, planning, vulnerability assessment, risk analysis, because there is no standard to measures these hazard, vulnerability, and risk, because different scientists used different methodology to assess the hazard, vulnerability, and risk. And we should must educate the people about the dangers surrounding them, like basically we have focused for the power sector, so we should educate the people, or we should at least sensitize the people about the disasters surrounding them. We should also proceed for the hazard analysis and risk analysis, and prepare a specific map or sector oriented, and we call, or we look forward the TM plan for the power sector. So thank you very much, and back to you, sir.
Thank you very much, Dr. Kaul, for such a wonderful presentation on the basic elements or basic concepts of disaster management, focusing the power sectors. Every individual should know the basic of disaster management, as disasters can strike anybody, anywhere, at any moment, especially if we are unaware of or unprepared to mitigate, resist, or cope with these effects. Disasters results in massive losses, including high death rolls, irreversible damage, unforgettable misery, as well as jeopardizing human existence, growth. So individuals or community that is well aware, well informed, well prepared is better able to prevent, to lessen, or cope with disaster risk than one that is unaware, uninformed, and unprepared. And so as a result, all the stakeholders, information, expertise, actions, all these are critical for healthy disaster risk reduction and resilience setup. And also we need to focus on building capacities at local levels, as advocated by our Honorable Prime Minister in his 10-point agenda. As disasters, they disrupt the functioning of not only industries, major industries like power sector, also of our community, of our society, that can cause suffering, loss of humans, material, as well as economic losses, environmental losses, and thereafter affecting human development as a whole. So there is need to develop the capacity. There needs to enhance the capacity, skills of the relevant officials, of the relevant stakeholders, as well, besides the local communities, to strengthen the actions for disaster risk reduction and resilience. So thank you very much, ma'am, once again for your wonderful presentation. So moving to the next presentation. For the next presentation, we are having with us Dr. Gautam Kumar. Sir is working as an assistant professor in National Fire Service College, Nagpur, which is also a part of Ministry of Home Affairs, Government of India. And sir teach electrical concepts of fire, fire protection, electrical fire safety, fire arson investigation, renewable energy systems, and direct research projects in the area of fire engineering related related to this airport fire, electrical tax and fire, IoT based firefighting equipments, smart hybrid fire electric vehicles, and so on. And also his broad area of research focuses on power system optimization, on hydrothermal scheduling, solar photovoltaics, and wind integration, etc. And he has also published a good number of research publication, around 35 in various international and national journal conference proceedings, as well as sir is also an advisory member to Public Service Commission for this Gujarat, Maharashtra, and Uttar Pradesh. And with these words, I pass on the stage to you, sir. Over to you, sir.
Thank you, sir. Thank you for your introduction. And it is also great privilege to work with the NIDM. Also, I'm having a special thanks to Professor Suryakumar sir also for inviting me and your continuous efforts for this. So, is my screen is visible, sir?
Yes, sir, your PowerPoint is visible and you are audible as well.
Oh, thank you, sir. This basically this presentation we made before starting to my presentation. The disasters in power sector, which is mainly focused on the electrical safety procedures and some kind of codes and standards in terms of manuals. All these aspects which are the listed in the power sector in India, outside in India, I will try to cover. Before moving on, myself, Dr. Gautam, has a introduction as me. And my flow of presentation, it will be like what are the disasters presently in the power sector in terms of fires and in terms of hazards. And in my second topic, what kind of electrical fires that we are having a huge issues. And in the third, I used to focus on the what kind of safety procedures till date they are following and what is we need to follow at the safety procedure at our level during any kind of electrical shocks and any burns. And at the last, I will try to float the all electrical safety standards which are following in India with codes and Bureau of Indian Standards, the literature, as well as the outside in India, what kind of European and US standards presently following regarding to the electrical fire safety in the power sector. So move on to the flow. This is the original power system and power sector which already been everybody having a some kind of gist of this power sector. The part is it is the first generation point of view, then we have the transmission, then we have a distribution. So these are the three parts which always used to cover under the traditional power sector. Now in this traditional power sector we always used to face some kind of faults, failures. Sometime it will be leads to fire, sometime it will be leads to disasters. So I will try to cover what kind of areas generally in the power sector which can be able to happen in the power sector. So these are the common disasters. These are the some of the common disasters which already been taken in the electrical world. So the first disaster is like there are some kind of substation. See these kind of disasters which inherently it will be happen in the power sector. This is basically one of the oil transformer transformer which has been kept at the distribution level. And this is the where we can able to have a some kind of wiring sizes, misinterpretation of the wiring, so that will leads to catch a fire. Sometimes we cannot able to handle these kind of situations. Is the video is visible, sir? Is my video is visible?
Sir, there is no voice, no audio in this video clip.
Now video is visible, sir.
Yes, video is visible, but there is
Oh.
some
There
box.
is no voice. There is no
Yeah.
voice, sir. I just need. Then it is okay. This is which is nearby to the places of the residentials. And last but not the least, it's kind of the entire substation failure. Once it has been created, there is a huge disasters which will be happen in the electrical sector. So these are some kind of failures which we always used to tackle the situation related to the electrical fires. So before moving on to the fires, some kind of electrical fires I just want. Over 20% of the fires which takes place worldwide and 40% of the fires which occur in India are due to the faulty electrical circuits. Due to faulty electrical circuits, the electrical fires, hazards and disasters which are happening day-to-day basis. And electrical hazards continue to threaten the safety of people and property in the forms of shocks, burns, injury, fire, and explosion. In the some kind of process industries, the fire arising from the electrical faults are also highly probable, especially in the industries which are having a chemical hazards. So generally, we used to handle with the hazardous materials. So that also will be prone. In service industries such as IT industries, telecommunication, some kind of interruption losses due to electrical hazards like fire in the server room, damage of expensive communication equipment, and data recovery, data loss, fires in cable and galleries, which could be substantial. So these are the main backgrounds related to the electrical fires. And when we compare to the electrical fire, electricity is one of the most common causes of the fires and thermal burns in homes and workplaces anywhere. Defective or misused electrical equipment is a major cause of the electrical fires. So with this introduction, I just wanted to give the overview of the how the fire is creating in the electrical scenario. So basically, as per as the definition concerned, it is a chemical reaction which usually required three things. So one is fuel source, second one is the oxygen, and third one is the ignition mechanism. If these three things are there, fire automatically will create. So how the chemical reaction will be happen when there is a fuel which will be heat will be produced with the fuel and which will be readily available with the atmosphere or oxygen. So there will be a triangle will form. This triangle will leads to generation of creation of the chemical chain reaction. This chemical chain reaction will create a fire. So in order to create a fire, these three are the major elements which essentially required: heat, fuel, and oxygen. Then only the fire will be created in any aspects of the electrical, mechanical, civil, anywhere which require the fire requires the three elements: heat, oxygen, and fuel. And in this, according to this, ignition, fuel, and oxygen, ignition can be anywhere. Either electrical ignition will be there, chemical will be there, thermal, radioactive, any kind of ignition can be done. And fuels also, it can be a like solid material like wood structure, any rubber material, any solid materials, liquids also like transformer oils, and some other oils, manufacturing industry oils, and all these oils comes under the liquids, petrol, diesel, ethanols, and all these will be comes under gaseous materials. Fuel can be anything, and oxygen is also readily available with the air mixture. It will be available in the atmosphere, and the people required to live for the 19%, and fire is only required 16%, which is lower than the present situation. So because of these three existing elements, the fire triangle will create. So how to extinguish, take any one component from this fire triangle? So fire cannot be able to serve. Either we can able to remove ignition, either we can able to remove oxygen or fuel. So any one of the element will leads to the suppression of the fire. So how we can able to suppress the fire? There is a process of elimination. The first process, if we removing the fuel from the fire triangle, generally we technically we call it as a starvation. So this starvation will remove the fuel from the burning substance, then fire will be suppressed. So again, when you are removing the heat from the burning substance, so automatically the fire will be suppressed, and when heat release, the fire is also will be removed. And the third is when you are removing the cutting away the supply of oxygen to the burning fuel or reducing the percentage of the oxygen. So it also we call it as a smoothing effect, and that also leads to suppress the fire. So these are the three process of elimination in the fires. According to the suppression also, there are different stages of the fire. The first stage of fire is preliminary as a generalized classification. Incipient stage will be there, critical stage will be there, uncontrolled stage will be there. And at the incipient stage level, generally we used to have these kind of fires. Generally we used to have at the inside the buildings or any chambers somewhere misinterpreted. So at this particular normal situation of fires, we can able to use the fire extinguisher either class A or B or C. So at the incipient stage, we can able to throw some kind of wet cloths, and some of the practical is throw some kind of water, and we use some kind of specialized extinguishers. Somewhere we use focus on the ABC extinguishers also. And these are the some of the classifications of the fires which can be able to take. Class A extinguisher will be used for the wood, paper, cloth, rubber, and some plastics. Class B also will be gasoline, kerosene, paint, and propane. And class C will be electrical equipments, metals like magnesium and titanium and sodium. So these are some of the classifications of the fire which will be utilized to extinguish the fire scenarios. Now the second stage of the fire, which will be at the critical stage. In the critical stage, generally we always used to adapt the systems like the sprinkler system. See, the fire is at the controlling level. When it is been increased, the electrical detectors will be detect the fire scenario, and it will be automatically open. And when it is being opened, the water will be suppressing media to suppress the fire. So then the fire will be extinguished. So it at critical stages we use the sprinkler systems or water mist technologies along with the alarm systems. So this is the standard operating procedure at the critical stage level when there is no man and human resources are not at the level to control the fire. So in the third stage of uncontrolled stage, generally we used to have to call the fire brigade. So in the third stage of the fire, we used to have the huge kind of fire, and the neither sprinklers nor any kind of other extinguishing medium will be worked out. So at this kind of uncontrolled stage of the fire, we call the local fire brigade to suppress the fire. So in this, the smoke layer will be formed, and the smoke layer will create a very huge losses for the property or as well as the human losses also. And during these conditions, we used to call the local fire brigade to suppress the fires. So in this way, generally the fires will be extinguished at the uncontrolled stage. So this is the basic fundamentals at what kind of level we can able to control in the, see, all these fires which will be rapidly grow on due to the electrical short circuits. So in this, some of the hazards that I have shown here, it is a electrical transformer hazard, substation hazards, some of the building fires, some of the natural electrical hazards, and some intermittent lightning strokes will be there. Some of the lightning strokes which will be directly catches a fires, and some of the wind equipments also will leads to the fire. There is a wind turbine which having a internal mechanism which always used to catches a fire. So these are some kind of natural, some kind of man-made disasters also there, some natural disasters also there. So in the form of the electrical safety and standard procedures, so we need to do some kind of alternative methods to suppress these kind of natural calamities to avoid the electrical failures, the entire grid collapse in the power sector. So see, these are some of the claims related to the wind turbine when it will be catches, either will be related to the wiring effects or will be related to the any failure of the missions, which will be taken care into the problems of the electrical fires. And these are some of the vehicle fires which always used to cause the battery fires. Now presently in the recent scenario, we always used to focus on the battery fires. So how these electrical vehicles has been proposed to, and automatically the electrical fires has been created in the electrical vehicles and somewhere in the energy storage systems also. This is the new area which can be able to cope up with the new kind of solutions in the disasters. And when we used to have some kind of static electricity, there are some kind of shocking and lightning things will be there. This also comes under the static electricity. So there is one particular static electricity which has been uh, happened at the Israel gas station. So in this, the basically there is a the pet the petrol the filler will always will be attached to this, and this is a static particles, either it will be charged due to the any of the thing. If any external device which have been in contact with this present accumulated charges, which always used to catch as a fire. So see, when the person which touches this kind of thing, so automatically the current will be discharged through the body, so it will leads to catch as a some kind of static electricity fires, which also will not be able to give any kind of fire prevention methodologies. These are some of the static electricity fires. So there are some kind of railway fires which have a huge attention in the terms of the rectification or any inversion methodologies. So which also has a carry forwarded to the remaining coaches. This is also one of the electricity fire. And the airport safety fires also, airport safety concern. So some of the equipments will always will be leads to catches a fire. So this also one of the key addressing issues in the present scenarios. And overall, in a electrical fire, electrical safety norms or any disasters in electrical, so the mode of ignition either will be arcing or sparks or static discharge in explosive environment, or high resistance contact or joints causing excessive ohmic heating without arcing, and lighting and high voltage transients, and another will be the short circuit and arcing. So these are the broad mode of ignitions to the electrical fires or electrical hazards. When we come to the main basic causes of the electrical fires, so the first will be the cable or wiring faults. So in this, second one will be the equipment faults, and third one will be the poor design and installation faults, and operation and maintenance faults, and external factor. These are the main basic causes that we have been encapsulated from the past histories of the electrical fires. So these are the 5 categories which has been continuously studying, where the cable and wiring faults, equipment faults, poor design and installation, and operational maintenance. When we come to the cable and wiring faults, there are some kind of damaged insulation. Like there is a damaged insulation, still the wires will be kept in the open condition. So which also will catch as a fire. and overload of the wiring. See, there are some kind of extension box which doesn't have any current carrying capacity of more than 4 amperes or 8 ampere. Still the people will make use the multiple loading of that particular aspect. So it also comes under the overloading of the wiring and inadequate sizing of the wiring. So when we wanted to run any high rated motors or any other industry equipments, so we require some kind of adequate sizing of the wiring is required. So in this also the majority of the electrical fires will be created. And when inadequate protection, when we require some kind of adequate protection which is inherently being created at the junction box levels or any the server rooms, so we require some kind of adequate protection. So this is also one cause of the electrical fire. And some animal chewing through the wires which also will be open to the atmosphere, so will create a fire triangle and it will be catch up a fire. And some defective cables or wires, so some of the defective cables are cables and wires also will be utilized and causes of the electrical fire. When we comes to the equipment faults, so it will be aging and aging. So main it is a wear and tear. Some of the old equipments or instruments which already been damaged, still people are people are utilizing. So because of that also somewhere it will be feel like that, because of this reason also it will causes of electrical fire. And when it comes to the environmental conditions, that environmental conditions also uh, not supported with the electrical fire, like lightning resistance and all, even the normal catches of the fires also. Poor ventilation for the HVAC also. So majority of the hostel fires which has happened in the recent past, that also will be comes under the poor ventilation effects. And the basically related to the ICU rooms. And fourth one will be the inadequate protection. So even we can able to overload at the present situation of these extension boards, but it required each and every load will have a advocate protection with the fuse. At least minimum one fuse will be attached to the concern um, concern load. So third will be the poor design and installation faults. When it comes to the non-compliance with the standards and codes, so we need to follow some kind of standards and codes. These codes and standards will I will explain elaborately in the subsequent slides. And inappropriate cable sizing also we require some kind of codes and standards. And in advocate overloading and short circuit protections also, and poor workmanship also, inadequate measures against the spread of the fires. So these are the main basic elements that we can able to cope up with the situations. And when it comes to the operation and maintenance, the poor maintenance and housekeeping at the site, that also inadequate routine inspection and testing, and lack of skilled and trained electrical staff for operation and maintenance. People doesn't have any trained staff, so basically they will go there and they will verify either by calling to the concern in charge or some other trained person. So it also leads to some kind of uh, causes of the fire. Placing of the flammable substance very close to the electrical equipment and cause the damage during the general renovation or repair works also. So it also use some kind of operational maintenance and falls. Some of the external factors also which leads to causes a electrical fire. The first external factor is lightning effect, and second one is the any abrupt switching of the two or more uh, injections of the some high voltage switchings or fault transient which causes an arcing faults. So immediate switching of the high voltages loads also will cause electrical fires. And fires, smoke spreading from the nearby instance also will reaches to the cascading fires. Change of operating environment also will leads to the external factors. So basically all these basic causes like the cables and wiring and equipment and faults and poor design and installation and operation and maintenance faults and external factors, all these factors which leads to causes of a electrical fire. When we comes to the common types of electrical hazards, the first thing is it's a overload hazards. If too many devices are plugged into a circuit, or the current will heat the wires to a very high temperature, which may cause a fire. If the wire insulation melts, like suppose there is a concrete construction, inside the wiring will be there. So we do not know outside there will be a switch and plug-in socket will be there. So if keep on overloading inside the wiring, it will be melt through the walls. So these kind of melting points we cannot able to identify it. So in a longer duration, it may collapse the structural orientation. So these kind of arcing may occur causing the fire in the area where the overload exists, even inside the wall also. So this is the major problem presently that we are facing, how to overcome this kind of overloading effects inside the walls also. And second common type of electrical hazard is contacting with the overhead lines. So some of the villages, they are having some kind of attention that if any wire will be meshed, they will always will be keep into the next. So because of this region, there will be may have a three-phase short circuit current will be flowing through that particular meter. And cranes are also not only the equipment that can reach the overhead overheads, some kind of ladder, suspension, small basket. And risk is mainly it will be electrocution and burns will be false. It will be comes under the contact with the overhead lines. So when contacting with the energized sources, any live wire which is carrying current carrying, and if you are touching that particular wire in the entrance, so automatically there will be live parts will be damaged and the current will be exit the whichever the line. So when it will be grounded, so the electrical shock or burn, sometimes it will be happen to complete paralyzing of the body. It's also the part of the electrical hazard. And when we comes to the severity and effects of an electrical shock, which depends upon the number of factors, one is the pathway through the body, and second one is the amount of the current, length of the time exposure, and where the skin is wet or whether the skin is wet or dry. For example, if we consider 1000 milliamperes will be equal to 1 ampere, and therefore 50 milliampere, 15,000 milliampere means 15 ampere circuit. For example, if it is below 1 milliampere, we don't have any kind of reaction. Generally, it is not perceptible. But if it is 1 milliampere, which is very close to one, greater than 1, so there will be a faint tangle movement will be observed. And if it is 5 milliamperes, single shock felt not painful but disturbing. But disturbing, average individual can let go. Strong involuntary reactions can lead to other injuries. And 6 to 25 milliamperes women, it is for the women, painful shock will be there, loss of muscular control. And 9 to 30 milliamperes, the freezing current or let go range will be there. And 50 to 150 milliamperes, extreme pain will be there, respiratory arrest, severe muscular contraction, death is possible. And when it is comes to the 1 ampere to 4 amperes, so rhythmic pumping action and heart seizures will be happen, muscular contraction and nerve damage. At this particular situation, we require the CPR. And if it is more than 1 ampere or 4 amperes, the above the 10 amperes, the cardiac arrest and severe burns, death is 100% probable. So these are some kind of standards which have already been mentioned in the codes and standards that we shortly discuss. And when it comes to the damaged or bare wires, the fault current may travel through a body, causing electrical burns or death if the power supply is not grounded, a path has been broken, there are some kind of live parts or bare wires will be happen. So these are some of the different examples which always have a damaged wires. Even some of the people always used to pin in the electrical circuits. These are some kind of damaged wires. Extreme conditions and rough treatment can change the electrical equipment from safe to hazards. In this, the basic electrical hazards, generally we call it as a B safe. B means burns, E means electrocution, shock, S means shock, arc flash or arc blast under the same, and fires will be happen and explosions. So when it is comes to the B safe with the electrical hazards, B in the sense of the burns. The most common shock related injury, non-fatal injury, occurs when you touch electrical wiring or equipment that is improperly used or maintained. So this is the first category of burn, it is the second category, and it is the third category. So as much as 80% of all electrical injuries are burns resulting from an arc flash and ignition of flammable clothing. So this is the one way of burn which comes under the electrical shocks. And next is the electrocution. Electrocution in the sense death due to the electrical shock. We call it as a electrocution. So it is 100% fatal and meaning to kill with the electrical shock. Either it can be intentional or it can be natural. So this there we need to focus on the some kind of results when a human is exposed to a lethal amount of electrical energy. An average of one worker is electrocuted on the job on each day in the power sector. And there is a shocks that body becomes a part of electrical circuit and reflex response to passage of the electric current through the body. And there are some kind of arc flash or arc blast, and arc flash suddenly release the electrical energy through an air when a high voltage gap exists and there is a breakdown between the conductors. So this kind of arc flash will be happen, so, which is very nearer to exposing to the breakdown of the conductors. And when it comes to the arc blast, high voltage arcs can also produce considerable pressure waves by rapidly heating the air and creating a blast. So which is very any closer explosives are there. So arc flash and arc blast will be happening. And it will contains a high intensity of the flash. So when it comes to the fire, fire may be most results problems from the fixed wiring, problems with the clots, plugs, receptacles and switches also cause electrical fires. So this is the one kind of fire, and this is the second, third, cabin fires, and the junction box power db fires, and some kind of control room fires, or any these are the server room fires and TV, some kind of equipments or computer fires. So these are the major fires which always used to have results from the problems of fixed wiring. And when it is comes to the explosions, electricity ignites explosive mixture of material in the air. So these are the main two all hazards of the equal importance. So lesson focuses on the eliminating the major electrical hazards. So when it comes to the electrical emergency situations, what we need to do in an electrical emergency. So for a low voltage electricity, for example, if it is greater than 50 volts and which is nearby the 110 volts of DC, generally we used to follow this kind of standard procedure, remove the source of electrical supply and commence the CPR if trained. If the people have been trained, commence the CPR, call the emergency number on site for the low voltage. For high voltage electricity, which has been happened, uh, maximum 1 kV greater than 1000 volts, the call the emergency number for your side. Don't go near the casualty also, and do not touch the casualty or try to free them with anything. So these are the basic procedural standard operating procedures that we used to adopt for the any kind of electrical emergency. So when it comes to the safety methods or safety procedures, so better to maintain a safe distance from the overhead power lines, staying away for the one of the following the next slide following table, which clears the line clearance distance from the various voltages. If it is suppose 50 kV and it will be the minimum clearance distance of the 10, or 50 to 200 it will be a 15, 200 to 350 it will be a 20, 350 to 525, 35 and 45 and established by the power line or this. So who is qualified the person with respect to the electrical transmission and distribution. So these are the minimum clear distance and safety measures which has been adopted by the electrical codes and standards. So the second category of the using earlier, generally we use the fuses to terminate the wires, and second after that we use the circuit breakers. After that MCBs are there, after that ELCBs are there, earth leakage circuit breakers, miniature circuit breaker, circuit breaker. So these are the trend has been followed. Now the present use is the ground fault circuit interrupters. where this is the ground fault circuit interrupter and the first and portable and CB with the GFC. This device protects you from the dangerous shock, basically. So this detects also a difference in current between the black and white circuit wires, and if a ground fault is detected, the GFCA can shut off electricity flow in as a little of 1/40 of the second, protecting you from the dangerous shock. This is the widely used one of the safety method. And second, the element which recently been conducted at the different levels of thing, is there any fire which will be happen nearby the power DBs or any CBs in the electrical room? So if we create some kind of intentional fire there, an automatic suppression system need to be initiated such that the suppression methodology will be initiated. So this automatic quelling system will need to be designed such that all the electrical fires which have been crossing the threshold values. So it is also one of the safety procedure which can be able to utilize it. See, automatic suppression system will be activated, automatically suppress the fire instead of going there and to keep on the continuation checking. And the third one is the power source identification. Mark all breakers accordingly for the circuits they protect. Mark all disconnect means accordingly the equipment they service in service. Identify all voltages with the proper labelings. And fourth one, inspect probable tools and extension cords. So workers need to inspect the extension cords prior to their use for any cuts or abrasion. And electrical hand tools that are old, damaged or misused may have damaged insulation side. Use power tools and equipment as designed. The follow tool safety tips to avoid the misusing equipment and follow manufacturing. So some of the like suppose with the presently there are a huge transformer failures and transformers fires are happening in the industry, in the generation or in the majority of the time it will be uh, above the 5.5 kVA, and all these transformers which are being at the level of generation companies, even in the transmission companies also we used to find the transformer fires. So these kind of fires will be need to be ignited with the some kind of specialized equipments by using the deluge valve systems installations. So how to cope up with this kind of transformer fires? Generally, the people will always used to adapt some kind of automatic fire detection system will be there. So this will be comes under the active fire protection systems are there. Instead of rather than the besides electrical fire protection schemes and systems are there. Even we have the Bachol's relay protection also there. But still there are some kind of entities which need to be go beyond the active fire protection and passive fire protections. So these are some of the glimpses related to the deluge wall systems also. Some of the transformers having a deluge wall systems. Even in the large fires also we can able to suppress the transformer fire protection systems. This is also one of the removal of oxygen or by smoothing method. One of the method that we have been discussed for the one of the smoothing such that the suppressing of the oxygen or smoothing the way we utilize it for the cooling purpose. So this is the material where it will be the suppress the oxygen levels and will comes to under the cooling effect. And these are the some of the tool safety tips It will never carry any kind of tool by the cords, never hang the cord to disconnect it. Keep cords away from heat and oil and sharp edges. Disconnect when not in use when changing accessories such as blades and bits. Avoid accidental starting. Do not hold any kind of fingers. Use gloves and appropriate footwear. Store in a dry place when not using. Don't use in wet or damp environments. And keep working areas well light, and ensure that the cords do not cause a tripping hazards. Remove the damaged tools from the additional use. Use double insulated tools. So these are the some kind of tool safety tips which regularly being used in the electrical safety methods. Now, when we comes to the personal protective equipments, PPEs, use some kind of electrical rated PPEs when working in areas where there is a potential electrical threat is there. So when we comes to the changing of the live wires, so we need to use the proper gloves and which will be carried forwarded to trip on the circuits, and gumboots, some kind of specialized suits when we are working with the areas where we can able to have a potential threat related to the electrical. And advance some of the electrical fire preventive methodologies have been initiated in the Western countries. So these are some kind of thermal monitoring systems where they used to install as a smart meters. These smart meters will always use to sense the temperature rises and falls, and which will be captured in the thermal monitoring system. So which immediately respond to the concerned operators to suppress or to take some kind of remedial action on this. And when all these related to the some kind of safety procedures and safety manuals, safety equipments that we have discussed. Now the electrical safety standards, Indian standards that they are following are in the field of this electrical engineering. Basically, these engineers and other professionals, they will get exposed to electricity directly or indirectly during the generation, transportation, installation, and some kind of utilization also. Such conditions might cause hazards if accurate safety measures are not taken. Then what we need to do is to promote the safety and the right usage of the equipment. There are certain rules and regulations have been formulated by the Bureau of Indian Standards. In the Bureau of Indian Standards, there are five principles they have been adopted as per the complete gist I just explaining here. There, the first perspective is to safety, and then easy of use and adaptability of the standards. Some simple technology will be used, value for the money products, and the last is energy efficiency and environmental friendly. So these are the five basic areas which have been focused to create some kind of standards in India. So these are the BAS, Bureau of Indian Standards, has published all Indian standard codes for the public safety standards in order to promote the right information, transparency, and accountability in proper manner to the public. These are the some of the glimpse of the standards, including all the standards which can be. I already listed out the each and every standard will require some kind of special attention to read and to have some kind of brief on this. Like suppose let us take IS 3034 will be the fire safety of the industrial buildings, which is the part of electrical generation and distribution station, and graphical symbols IS 2032, and practice for interior illumination, insulation coordination. These are the different standards. And voltage transformers, current transformers, guide for the transformers, and types of hazard areas, PVC insulating cables, HRC fuse, and guide for heavy duty air brake switches, insulating oil for transformers and switch gears. And these are the different Indian standards. And 2516, 3427, 722, and 1951, 2951, 5124 for installation of maintenance of AC induction motors, insulating of oil transformer and switchgear 335, power transformer, there is a IA standard 2026. These are the list of the Indian standards that they are still using in the installations of this. And 2099 gas operated relays, guide for the stationary cells, guide for the current ratings for the cables, electrical cables, turbine type generators 5422, and 7306 methods for determining the synchronous emissions quantity. So these are the some kind of Indian standards that they have been adopted for the installation, commissioning, and maintenance. As far as the outside India concerned, there are some kind of um, associations. Like suppose one of the association is the National Fire Protection Association. They have made their own codes and standards which are very relevant to the fire standards also. So these are the list of the standards which they are majorly focusing on the electrical point of view. So NFPA 70, A, B, E, 73, 77, 78, 111, 4967, 97, 99, 791, which will be recommended for the practice and procedures for the unlabeled electrical equipment evaluation. And 805 will be speak about the performance standard for the fire protection for light water reactor electrical generating plants. 806 will give the standard for the advanced nuclear reactor electrical generating plants. 850 will recommend the fire protection for the generating plants and high voltage HVDC converter stations. 851 will be meant for the hydroelectric generating plants. 1078 will be meant for the electrical inspector professional qualifications. These are some kind of gist of the standards which are being using in day-to-day basis in the outside India. So these are the list of standards which I wanted to share to you. So with this, my closing remarks are, so I have discussed various scenarios of the causes of the electrical fires, and some of the electrical fires may be prevented by some kind of good design and installation of the work, equipment fit for if purpose and operating environment, proper operation and maintenance practices need to be initiated. So as far as the comprehensive electrical safety audit concerned, there should be a fire safety professional which need to be require a electrical safety audit. As otherwise, the Bureau of Energy Efficiency already having a certified energy auditors are there. So from there, there should be some kind of electrical safety audit should be done at least once in a year. And these are some of the references that we have been gathered as per the IEEE standards and NFPA, some firefighting operations, some of the electricity safety operational manuals. And thank you. Over to you, sir.
Thank you very much, sir, for your wonderful session. And enriching the knowledge of our participants by sharing your vast knowledge about the disasters, the probable disasters in that can be in the power sectors. And you also highlighted the classification of fire that one needs to know so that they can eliminate it. And you also provided insights on the different stages of fires and what will be the scenario at different stages. Different modes of fire ignitions were also discussed by you during your talk, besides a number of Indian standards for the electrical safety. And as you highlighted, that fire is a big threat that can cause loss to human life, as well as devastation of structure and infrastructures that are related to power sectors. And how disasters due to fire normally remains localized to a particular installation until the or unless tripping of the entire power plant cause disturbance in the transmission grid by way of overloading or leading or tripping of this power station or transmission line that are connected with the grid. And the damage caused by this fire accidents, they generally take excessive time for restoration. So proper upkeep of fire protection equipments, fire protection systems, they could ensure timely availability of these systems for putting out the fires before they could result in any disastrous situations. So once again, thank you very much, sir, for your wonderful presentations. Sir, there are a couple of questions raised by our participants. Sir, this question is from Amrit Singh. This question is, sir, is there any incidents in your knowledge when a fire accident happened in power sectors due to any natural hazard such as lightning? Gautam sir, are you there? I think there is some technical issue with our experts. Okay. Gautam sir, should I repeat the question?
Sir, I am unable to listen the question. My internet connectivity problem.
Yeah. So, okay, I will
Can you
repeat
repeat the question, sir?
Yeah. This question is from Mr. Amrit Singh, and his question is basically he want to know if there is any incident in your knowledge when a fire accidents that happen in power sector is due to natural hazards such as lightning.
Okay. Generally, when it is happen natural hazards, we have the electrical protection schemes are there. But still, if it is bypassing electrical protection schemes, we are unable to do any kind of thing, sir. So at that particular situation, we need to go for a firefighting systems. Am I
Sir,
audible?
another question is from
Sir?
yes, sir, yes, sir. Another question is from Miss Ruchi, and her question is that sometimes it has been seen that people stealing electrical power from a nearby electricity pole. How safe is it in view of any electrical accident, and how we can sensitize people not to take not to do such a things?
This could have been happened in the electrical also. So for this, there is a specific department in the power sector, cyber security. Cyber security and internal security already been initiated. Phasor measurement units which are already been placed in some of the remote locations where we can able to tap these kind of security threats. So when it is being detected any kind of threat is there, automatically concern discom people will go there and remove the connections. So already been initiated by the cyber security. It's a cyber
Thank you
threat.
very much.
So generally whenever
Yeah.
tapping any kind of functions are there,
Thank you very
so
much,
people
sir.
always
That's all
used to
for that.
steal the electricity from there.
Thank you very much, sir. For
Thank you,
that's all
sir.
for this question and answer session. I can't see more questions from our participants. So once again, thank you very much, sir, for joining us, for sparing time for us and delivering this wonderful lecture. So that's all for today's technical session. But before we say adios to each other, I take this opportunity to thank both the eminent speakers of today's technical session, Dr. Gautam Kumar, who is Assistant Professor in National Fire Service College, and Dr. Harjeet Kaur, Junior Consultant at GMR Division NIDM. They take out their time from their busy schedule and they share their valuable knowledge and their experience with us during this technical session. So I thank both of them being a part of this the first day of 3-day online training program on disaster management for power sector. So it was very really nice to listen to both of you. With this, but before we close the first day, I would like to inform our participant because some are querying about attendance and e-certificate. So attendance is automatically generated in this Cisco WebEx platform. So there is no need to fill any additional this attendance sheet. And regarding the certificate, for certificate, it is mandatory that you should register yourself at NIDM training portal, and you should enroll for this 3-day online training program on disaster management on this for power sector. And also you need to keep in mind that your attendance, it should be 60% each day. That is mandatory for each certificate. And after the completion of this training program, you can download certificate from NIDM training portal itself after filling the feedback form that will be available on NIDM training portal. Once this training program will be completed, the link of feedback form will be available on the menu that is mentioned as completed event completed events. In completed events, this 3-day online training program will be listed, and there will be a link to fill the feedback form. After filling the feedback form, you will be able to get this link to download your certificate. So I request participants who have not yet registered at online this for this online training program in NIDM training portal. Please do register, as some of you may have joined this online training program through a link you have received from the WhatsApp group. So it is requested that please do register in NIDM training portal, and please enroll for this 3-day online training program. And regarding tomorrow, there will be 3 sessions, 3 presentations in the technical session of second day, and 3 speakers. They will be sharing their expertise on a variety of themes such as building climate change, resilience for electricity infrastructure, and one session will be on power grid collapse response and about restorations, and the last session will be on a preparation of disaster management plan, focusing the power sectors. So all are requested to join us before the scheduled time. Scheduled time of this online training program is sharp 2 p.m. So you can join us 15 minutes before the scheduled time, and same link will be used to join all 3 days. So once again, thank you very much to all the dignitaries, panelists, and as well as our participants who have joined us in this 3-day online training program. So see you all. Thank you very much, and please keep following all the precautionary measures for COVID-19. Thank you very much.